All right, good morning, good afternoon. Today we're going to be talking about 4.2 relations. Don't forget to like and subscribe to my video. Just kidding. All right, so today we're going to be talking about creating a table of values for known relations, graphing the relations on a coordinate plane, and then identifying the domain and the range of that relation. Okay, so part of our notes to start. A set is just a group of numbers, and you're going to put the group of numbers in braces. Okay, they're little, I'm really bad at them. They're these little guys right here. All right, a relation is going to be a set of ordered pairs. A set of ordered pairs. Okay, the domain is going to be the set of all the x coordinates. All of the x coordinates. The range is going to be the set of all the y coordinates. So when listed the domain and the range, you need to list them from least to greatest. Do not repeat any numbers within that set. Okay.
Go back.
Hold on, settle down. Okay, so I just want to show a little example of, relax, thank you. Relation, it's a set of ordered pairs. So something like this around, with brackets around it, 0, 1, there's an ordered pair, 2, 3. This whole thing is a relation. Then that domain is all of the x values. So 0, 2, and 5 would be the domain. And I'm going to write that in a bracket. So 0, 2, and 5. And we'll go through this later. And that would be all the domain. And then the range would be 1, 3, and 4, all of the y's. Stop. All right. Relations can be ordered pairs. So just written as ordered pairs. It can be written as a table. It can also be written as a graph. All of them are relations. The domain for these are going to be all of your all of your x coordinates or x values of your ordered pairs. So the domain is going to be written like this. Remember, from least to greatest. Again, your range is just going to be all your y's written from least to greatest. Okay, and then your graph is going to be these ordered pairs graphed. So -2, 3, I go over to -2 and up to 3. The next thing we're going to be talking about is expressing the relation right here as a table and a graph. So the first thing you're going to do is you're going to write 2, 6 here. So all the x values, the y values. So 2, 6. And I'm sorry? Yes, you can. So -4, -8, I would write -4, -8. -3, 6, and then 0, -4. And then after I do that, I want to graph them. So 2, I'm going to go over to 2, 1, 2, and then up to 6. 1, 2, 3, 4, 5, 6, and put a dot. I'm not going to connect them with the line right now. -4, -8, so over 1, 2, 3, 4, and down to 8. 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. -3, 6, -3, and up to 6. 1, 2, 3, 4, 5, 6. Oh, they should be at the same spot. 1, 2, 3, 4, 5, 6. That was an accident. And then 0, -4. 1, 2, 3, 4. So I've graphed all 4 of those points. And then I need to state the domain and the range. So I'm going to write the domain Remember, the domain is my x, and I want to put it in little braces. Remember, from least to greatest, so out of my x's, which is the smallest number, would be that -4, -3, then 0, then 2. And then I close it with a bracket. I say bracket or braces. Okay, then don't forget to write your range. And again, your range is going to be all your y's. So brackets, the smallest number here in my y's would be a -8, -4, 6. And do I want to rewrite that other 6? No. I don't want to repeat that. So our next example, express the relation, all these ordered pairs as a table and a graph, and then state the domain and the range. So we're going to go in, write -5, 2, 3, -1, 6, 2, 1, 7. If you wanted to, you could start writing them here from least to greatest. These would be least to greatest. These might not necessarily be, but then you have one already from least to greatest when you're writing the domain and the range. Not a big deal, but then I'm going to go and I'm going to graph them. So -5, 1, 2, 3, 4, 5, and then up to 2, put a dot. Then 3, 1, 2, 3, down to 1, 6, 1, 2, 3, 4, 5, 6, and up to 2, and then over to 1 and up to 7. 1, 2, 3, 4, 5, 6, 7. Remember, the first number is how much you go in or right to left, and the second number is how much you go up or down. Remember, you have to go in the elevator before you can go up or down it. Okay, so I have graphed my ordered pairs, and now I want to state the domain. Remember, the domain is the x. So you want to remember your brackets, braces. And from least to greatest, my smallest number is -5. Then we have 1, 3, and 6. And then my range from smallest. Smallest number would be a -1, comma 2, comma 7. Remember, you do not double or write that 2 twice. The next example is a word problem. Costs $3. Is this the one? Next one in yours? Yeah. Costs $3 per hour to park at the Wildwood Amusement Park. So make a table of ordered pairs in which the x coordinates represents the hours and the y coordinates represent the total cost for 3, 4, 5, and 6 hours. So we have per, so we're going to be multiplying every hour times 3. So our equation is going to be y equals 3x, because per hour, and x is the x coordinate is representing the hours. Okay, so we're going to create a table. We did this yesterday, where our x is our input, this is our equation, and this is going to be our output. And they give us what they want us to use, the 3, 4, 5, and 6. So 3, 4, 5, and 6. So I have to do 3 times the x, which now we chose 3, 4. So 3 times 3 is 9. 3 times 4, 3 times 5, and 3 times 6. So 12, 15, and 18. Then I have to go over and I have to label my parts here. So here we could label it as Wildwood Amusement Park, WW Amusement Park. My X, it tells me that the X represents hours. My Y represents the total cost. It doesn't give me any labels for my X and my Y axis, so I want to label like hours. I'll probably label by ones. So 1, 2, 3, 4, 6, 7, 8, 9. And then total cost, we could label it by, we want to label it by threes? So if we labeled it by threes, 3, 6, 9, could we count up by threes? So 3, 6. We want to just make sure that we would get to our top number here of 18. Then we want to label or graph our points. So 3 hours will cost us $9. So over to 3 and up to 9. Over to 4 and up to 12. Over to 5 and up to 15. So on and so forth. Did we answer all the questions? I think we did. We have one more, pretty much the same thing. We have a movie rental store. It charges $3.95 per movie. We have no other numbers. We're not. There's no base rate or base fee, so we're going to just have that y equals 3.95 times x. So if we rented one movie, it would cost us $3.95. 2 movies would be $7.90. 3 is $11.85. We're just going to put inputs into that equation. Total cost for the movies 1, 2, 3, 4, and then we're going to graph our ordered pairs. In this one, it does give us our labels for the y: 1, 2, 3, 4, and 0, 2, 4, 6, 8, 10. The cost is going to be your y, because it does tell you here the y coordinates represent the total cost. It tells us our x is going to represent the number of movies. So movies is down here. Okay? I'll come back to this in a second. So your assignment is page 281, 1 through 15 odd.